Hello, and welcome to Math Matters. I'm Miss Ogden, and today we're going to learn about how we can apply what we know about rational numbers to construct and interpret circle graphs. For this lesson, you'll need paper and a pencil or something else to write with. We'll pause for about 30 seconds for you to gather those materials. Now that you're ready, let's get started. There are a few learning goals for today's lesson. We'll have one math goal and two portrait of a graduate goals. Let's take a look at today's math goal first. I am learning to apply my understanding of rational numbers to interpret and construct circle graphs. By the end of today's lesson, I hope that you'll be able to interpret a circle graph using your understanding of fractions, decimals, and percents, and that you'll be able to create your own circle graph to represent fraction, decimal, or percent values. Our portrait of a graduate goals are focused on being goal-directed and resilient. We want to work on these skills in and out of school until they eventually become a habit of mind. The first one is, I persevere through difficult tasks and situations. That means that you keep trying even when it gets hard, and you don't give up. The second is, I learn from my mistakes and ask for help and feedback to improve my work. That means that you don't let mistakes get you down. You know that mistakes present an opportunity to learn, and you aren't afraid to ask for help or feedback along the way. Mathematicians are goal-oriented and resilient individuals. They know that math should make sense, and sometimes answers don't come to them quickly or easily. They have to keep going even when things get tough. They also believe in themselves and know that mistakes and challenges are the best time for your brain to grow. They believe that there's so much to learn from their mistakes, and we aren't afraid to ask for help when we get stuck. Over the last couple of days, we've been learning about the relationships between fractions, decimals, and percents. Let's take a moment to review what we've learned about percents. Percent means per 100 or how many out of 100. Percents are related to fractions and decimals. The percent symbol can be used to represent a fraction with a denominator of 100. Percents represent a part-to-whole ratio. Mathematicians are always noticing and wondering things. We're thinking about what connections we can make with the math that's all around us. Let's do some of that to get our brains going. Take a look at the models on your screen. You might recognize the model on the left from yesterday's lesson. What do you notice about these models? What do you wonder? Go ahead and jot down any noticings or wonderings you might have. You might have noticed that there are two models of Fox Chase Farm on the screen, or that both models have four colors that are similar. You might have noticed that both models show the same percentages, or that the sum of those percentages add up to 100%. Maybe you wondered why one representation shows a square and the other a circle, or why the graph keys look a little different. Now that you're thinking like mathematicians, let's learn a little bit more about data and statistics. Data is the term that mathematicians use to describe a collection of information. Statistics is the term we use to describe a process we go through to collect and present that information, which we call data. Believe it or not, you've probably been doing statistics since you were in kindergarten. The first step is to formulate a question. Mathematicians ask questions that we want to know more about, and we often collect data about things we're really passionate about or interested in. The next step is to collect the data, and we often gather this information through survey questions or observations. After we collect the data, we analyze it. This is when we'll decide what kind of graph we'll use to represent that data. The type of graph that we choose often depends on the data that we've collected. We represent data in graphs so that readers are able to read and interpret and analyze the results easily. And graphs always tell a story. For example, if I surveyed all the kids in my class and asked them to tell their favorite season, I'd probably construct a bar graph because I collected categorical data, or data that can be funneled into different categories. If I recorded the temperature every day for 2 weeks, I'd probably construct a line graph because I collected numerical data over time. The type of graph I choose should match up with the data that I collected. The final step is to interpret the results. When we read a text, we often think about the author's purpose or the message that the author might be trying to send us as the reader. Well, think of mathematicians as the author when you're interpreting and analyzing a graph. That mathematician or author had a purpose for collecting the data, and they're trying to tell you a story in some way through a graph. Today, we're going to zoom in on circle graphs. Circle graphs represent a part-to-whole relationship where each section represents part of the total. Circle graphs are used to represent percents or the frequency of something happening. They're usually partitioned into pieces that can be named by fractions, decimals, or percents. Circle graphs are particularly useful when representing large numbers, and they're sometimes called pie charts. Now we'll take a look at some examples of circle graphs from the real world. One of the most common ways that a circle graph is used is to represent a budget. A budget is like a spending plan that people use to track their expenses. Take a look at my budget on the screen. You'll see that each section of the circle graph represents one area in which I spend money. 25% of my budget is spent on debt or paying back money that I've borrowed. I spend 30% on rent and utilities, 10% on groceries and food, and 8% on entertainment. I put 20% aside into my savings, and apparently I spent 8% on other, which I couldn't tell you what that is right now. The sum of each piece of the circle graph will always be 100. Here's another example of a circle graph in the real world. This circle graph shows a representation of data collected from teachers that shows their favorite way to get exercise. We can see that walking is the most preferred activity and that other is the least. Again, the sum of each piece of this circle graph is 100%. Finally, here's an example that shows 6th graders Window 1 and Window 2 Math e-cart scores from last year. We can see that the number of students who score between 70 and 100% increased from 26% in window 1 to 50% in window 2. Now that you know a little more about circle graphs, let's construct one. The first step in the process of statistics is formulating a question. The question we asked 100 sixth grade students was, what is your favorite video game? The choices were Minecraft, Fortnite, Roblox, and Super Mario Brothers. Once we've formulated our question, our next step is to collect the data. We collected data from 100 sixth graders. Let's take a look at their results. 25 students chose Minecraft, 50 chose Fortnite, 15 chose Roblox, and 10 chose Super Mario Brothers. When we add up all the votes, we can see that all 100 students are accounted for. Now that we've collected our data, we're almost ready to construct our circle graph. But first, we need to understand how the votes for each game relate to 100, because that's the total number of kids that we surveyed. Graphs always have a title, and we'll keep it simple. Our title will be sixth graders' favorite video games. Circle graphs always include some kind of key to let the reader know what each section represents. Our key is going to show what game each color or section represents. Red will represent the percentage of students that chose Minecraft as their favorite video game. Orange will represent Fortnite, green will represent Roblox, and blue will represent Super Mario Brothers. Our sample size was 100 sixth graders. That means that we surveyed 100 sixth grade students about their favorite video game. We're going to use this chart to organize our data with rational numbers, or fractions, decimals, and percents. Rational numbers is the term that mathematicians use to describe those numbers. We know that 25 out of 100 students chose Minecraft as their favorite game. And I remember that 25 hundredths is equivalent to 1/4, or the decimal is written as 0.25. It's also equivalent to 25%. Remember, mathematicians are always on the lookout for connections, and our learning target for today is to use our understanding of rational numbers, or fractions, decimals, and percents, to interpret and construct circle graphs. So I can use what I know about fractions, decimals, and percents to help me construct my circle graph. From the chart, I can see that the number of students that chose Minecraft as their favorite game is 1/4, and I can easily represent 1/4 on my circle graph with a red piece. I remember that 1/4 is equivalent to 25%. 50 out of 100 students chose Fortnite, and we know that's the same as half. We also know that's equivalent to 5/10 or 50%. So I'll represent 1/2 or 50% of the circle graph with an orange piece. 25% represents the 25 kids that chose Minecraft, and 50% represents the 50 that chose Fortnite. So far, our graph represents 75 students, which is 75% of the data. And I know that's equivalent to 3/4, which I can see in the circle graph. 15 students chose Roblox as their favorite game. And I know that's equivalent to 15 hundredths or 15%. Let's represent that with a green piece. Now our circle graph represents 90%, or 90 out of 100 students. We're almost done. The sum of all the sections of a circle graph will always be 100%. If we've got 90% of our data represented so far, what percentage is missing? 10 students chose Super Mario Brothers as their favorite game, and that's equivalent to 1/10 or 10%, which we'll represent with the blue piece. When we add all of the pieces of the circle graph, the sum is 100%. The next step in the process of statistics is to interpret the data. Let's take a look at the circle graph to determine if each statement is true. Identify 2 true statements about our circle graph. Write down your thinking to justify and defend why you believe that statement is true or false. We'll give you about 2 minutes to do this after I read the statements. A. 2/10 of students said that Roblox was their favorite game. B. 1/4 of students chose Roblox or Super Mario Brothers as their favorite game. Twice as many students chose Fortnite than Minecraft. And D. 10% less students chose Super Mario Brothers than Minecraft. Let's zoom in on each statement and think through why they're true or false. A says 2/10 of students said that Roblox was their favorite game. Well, I can see that the green section represents 15% of the students, and 2/10 is equivalent to 20%. 15% is less than 20%, so statement A must be false. Another way I might think about it is that 15% is equivalent to 15/100, and that is less than 2/10. 1/4 of students chose Roblox or Super Mario Brothers as their favorite game. The statement says Roblox or Super Mario Brothers, and I know that word or means that I need to combine those amounts to find their sum. Roblox represented 15% of the students, and Super Mario Brothers represented 10%. 15% plus 10% equals 25%. And 25% is equivalent to 1/4. So this statement must be true. C. Twice as many students chose Fortnite than Minecraft. That means that the number of students that chose Fortnite should be double the number of students that chose Minecraft. Doubling is another way to say multiply times 2. And 25% times 2 is 50%. Half of 50 equals 25, and that's another way you might think about it. So, we just proved that this statement is true. And D. 10% less students chose Super Mario Bros. Than Minecraft. 10% chose Super Mario Bros. And 25% chose Minecraft. The difference between 25% and 10% equals 15%. So this statement is false. Now take some time to create 2 true statements on your own. Make sure you justify and defend why those statements are true. Feel free to share your statements with your classmates and teachers. Mathematicians also take time to reflect on what they've learned. So let's take some time to reflect on our learning today through the lens of Portrait of a Graduate. Remember, a couple of habits of mind that we're trying to develop as goal-directed and resilient individuals is persevering through difficult tasks and learning from our mistakes. Were any parts of this lesson challenging for you today? If so, how did you persevere or keep going even when things got hard? What did that look and sound like? Did you make any mistakes today? If so, did our discussion help you understand your mistake better? What does learning from your mistakes look and sound like? Take a moment to jot down your ideas about what these skills look and sound like on your paper. In today's episode of Math Matters, we learned about data and statistics and how we can use our understanding of fractions, decimals, and percents to interpret and construct circle graphs. As you reflect on our learning goals, how do you feel about your ability to read and interpret circle graphs? Do you feel like you could construct your own circle graph? Give a thumbs up if you've got it, a thumb in the middle if you're still practicing, or a thumbs down if you feel like you still need a little help from your teacher or someone at home. I encourage you to share any questions that you might have had today with your teachers. We're going to keep working with circle graphs for a while, so you'll have lots of time to practice your new learning. I'm Miss Ogden. I hope you have a great day and keep on counting.